Welcome to ClickMyProject.com. Now we are going to discuss about the title Runtime Adaptive Circuit Switching and Flow Priority NoC-Based MPSoCs. Now we are going to discuss about the abstract of this title. Network on chip architecture represents a promising design to crop which increases communication requirements in digital systems. Network on chip has emerged as a vital factor that determines the performance and power consumption of many crop systems. Thus, the VLSI technology is to modify NoC internal router arrangement, shortest path allocation processes, and neighboring router estimation control, with the significant increases in the number of promising elements in NoC-based MPSoCs communications, a critical resolution for performance gains and quality of service. The main gap observed in the NoC-based MPSoCs is the runtime adaptive technique to meet quality of services. Thus, the mesh topology is used to identifying the shortest path. By identifying the shortest path, the quality of service of the system can be obtained. Now we are going to discuss about the flow of this title. In the NoC architecture, first we have to set one router as the source router. In the source router, there are 8 data as the inputs. In this NoC architecture, we are using the mesh topology based the NoC design. So using this router, first we have to identify the neighbor router estimation with the help of weighted calculations. In the weighted calculation is mainly focused by the packet switching, circuit switching, and virtual circuit switching. These switches considers or connecting the internal connection between internal connections of the router position levels. The weighted level is used to analyze the data section control level of router architectures. Then neighbor router estimation is the data transfer process is to analyze the all router position level and to find the shortest path between the source and destination router. So we check the low weighted bit level for nearest neighbor router estimation process. This process is to analyze the main router weighted bits. The number of router estimation control is used to check the shortest path identification control. Then we have to identify the destination router. So for the destination calculation is to calculate the low distance route for shortest path identification. The minimum distance level is to identify the shortest route between the source and destination. The neighbor estimation process is to maintain continuously and to reach the destination process. To stop the destination calculation for neighbor estimation process. So the neighbor router estimation is finding the minimum, then it goes to the next neighbor router estimation, then final destination router design identifies the shortest path estimation. If the neighbor router estimation is greater, then the condition will be set again. So by this the router identify the shortest path. Using this we can also identify the quality of service of the system. Now we are going to discuss about the simulation synthesis result of this project. So for that, first we have to click to this designing window. Then the designing window will be opened. In that we have to click to this designing page. Then first we have to see the simulation result. For that, click to this simulation and run to this simulation behavioral model. The simulation window will be opened. This is the simulation window of the NoC design. So first we have to set this forced constant, then give the value as 1 to the reset value, then run to this design. Then we have to give 0 to this result value, then give run to this design. Then run the design up to the D output value will be obtained. So using this we have to finding the shortest path by using the NoC architecture. Now the layout will be updated. Then give full zoom to this design. Here we are seeing the finding the shortest path. So first shortest path will be in P5, then the shortest path will be in P10, then finally the result will be updated in P15. So by using this NoC architecture we can identifying the shortest path. Now we are going to see the implementation result of this process. For that, first we have to click to this implementation, then run to the synthesis existing. Then the synthesis existing will be successfully run. Then click to this plus mark, then give run to this RTL schematic and give OK and add create schematic. The schematic of this mesh router of NoC design will be updated. Then zoom to this full design. So this is the full implementation RTL schematic diagram of this NoC architecture. Then now we are going to see the technology schematic of this process. For that we have to run to this technology schematic, then give OK, then add, then give create schematic, double click to this mesh router and zoom to full view. Now we are seeing the full view of the technology schematic of this process. So by this we are seeing the implementation diagram of this NoC mesh router architecture.